Hi everyone. My name is Debika. I'm an AI ethicist here at Business School of AI as well as Global South in AI. And I'm here today to host the WeeklyWed Global Speaker Series, which we have different speakers come in and tell us something that we didn't know about AI or whatever the topic may be. And we're always here to learn. We kind of think of it as like a cool lunch and learn in our organization. And today we have Mounir Shita here, and he's going to tell us all about his research in AGI, and he's joining us from TechCrunch Disrupt. And before we get started, I do want to let everyone know that this is a live and recorded event. So if you don't want to be on camera or you don't want your audio recorded, please feel free to join the chat. Mounir, welcome. And um, before we also get started, I do want to say Sudha, our founder, she actually has two courses out live right now. One partnered with LinkedIn, and it's live right now, and another one here where she's basically teaching you everything you need to know for agent AI for product leaders, and we have a special code in the chat today too. So you will get a little bit off and you'll get to see what this course has to offer. So please feel free to look in the chat. And I put the code and the class in there, the course. And Mounir, welcome. So
Thank you.
hi. Hi.
I am for having me here.
I'm going to spotlight you. There you
Oh, okay. Oh, I should
go.
just jump into this. So, yeah, I am going to share a little bit about our research in artificial general intelligence, or we like to use the phrase super intelligence. And I hope by the end of my presentation today, you'll understand why. And then I'll share a little bit about what's going, what we heard at Disrupt when it comes to AGI. So let me share my screen.
Yeah, there's a lot of conversation about AGI and what people think about it. So glad you're here to clear it up for us in a sense.
Yeah, so I will warn everyone that what you're going to hear today is a very contrarian view to general intelligence. Um, so I titled this a scientific approach to superintelligence. But let me introduce myself first. So my name is Mounir Shita, or everyone calls me Mo. So I've been in this world since 1997, and my path into this was through, believe it or not, a VCR, which I'll share that story. Um, but my goal has really focused on researching the nature of intelligence. Because if you're going to build machines that are intelligent, I think we ought to kind of know what intelligent is. Um, from there, we got a theory of what's called theory of general intelligence. It was accepted for presentation at International Conference for Advanced Research in Science, Engineering, and Technology a few years ago. And I wrote a book, Science of Intelligence, which is a much more deep dive into this theory about the nature of intelligence, how it relates to the cosmos and artificial intelligence. Um, well, much more deeper than what I'm going to go through today. What I'm going to go through today is like the tip of the tip of the tip of the iceberg. And currently building a new startup called Aeronova Global. It's my fourth venture, where I have a co-founder, Steve Taylor. And in this startup, we are trying to turn the theory of general intelligence into actual software code. But I do want to start out by saying that in the world of AI or AGI, there's a lot of talk about science. There's a lot of people who have titles that says AI research scientist. And I think it's very misleading. So I just wanted to start out by the definition of science. And it's not my definition of science. You can go and pick up a dictionary from 500 years ago, and it'll say the same thing. Science is acquisition of knowledge from the natural world. Science is not trying to make algorithms, unless algorithms were grown by farmers. Algorithms are engineering, not science. So when I say a scientific approach, what I'm trying to say is what you're going to hear today is engineering that has a true scientific foundation. But my journey started back in 1997. Actually, it started way before that. Um, I grew up a Star Trek kid. Commander Data fascinated me. And I grew up thinking, you know what? If we can talk to machines, we're going to get closer and closer to Commander Data. So last year at the University of Southeastern Norway, I built a speech recognition module for a VCR. Now, if you don't know what a VCR is, this is what we used back in the Stone Ages to watch movies. Um, but it worked. I could talk to it. But I was also super disappointed because nothing about that VCR felt intelligent. Nothing about it felt like a step closer to Commander Data. And that is the first time it occurred to me that I didn't know what intelligent meant. And so I kept asking myself the question is, well, what is intelligence? And I figured, again, this was the early days of the internet, so we still used the Stone Age version of the internet, which is called a library. I figured a quick trip to the library will tell me what intelligence is. Just find a book about intelligence and it'll tell me exactly what it is. And it didn't. In fact, it told me there has never been a true scientific inquiry into the nature of intelligence. It's remained in a philosophical space. And AI people kind of talk about it. Psychologists kind of talk about the human version of it. But truly what it is, that has never been a scientific topic yet. I figured, well, it's 1997 or 1998, whatever it was, and it's been decades since Alan Turing first published his paper. So I figured I'm going to go through the history of AI because clearly these guys must have figured out something. And again, I got really disappointed. And I'm going to tell you why I got disappointed. I'm going to show you a part of Alan Turing's paper. So if you're not aware of Alan Turing's paper, it's called Computing Machinery and Intelligence. It is considered the starting point of AI. And it's one of the most referenced papers in AI. Alan Turing, very famous guy, has been, well, I don't know if they consider him a godfather of AI or the father of the AI era, but he's well regarded. However, in my book, I asked a question. Did Alan Turing unintentionally reject science? Now, I want to make sure I understand this. Alan Turing is not a science denier. He is far from it. But did he, in his paper, unintentionally reject science? And what I'm talking about here is on the 10th page. This is something that historians not ever really pointed their finger in the 10th page, he says the original question, can machines think, need to be too meaningless to deserve discussion. And that stood out to me because that is not a meaningless question. And it absolutely deserves discussion because we got to know what it means to think because that's going to lead us to intelligence. And that might actually lead to a scientific inquiry into intelligence. Alan Turing instead said we can use engineering ways or logical analytical ways to measure intelligence. And that's where the Turing test comes from. Ever since this paper, everything that has been going on in artificial intelligence is engineering based. Not a single thing we have done in what is that, 74 years now, has a scientific foundation. When I say scientific, is the nature of intelligence. It is not based on any knowledge or any theory of the nature of intelligence. Some are based on a psychological view of human intelligence, but not the nature of intelligence. And I guess there's something, I'm going to be a little extreme here, but I believe this is a truth that the belief that you can engineer something that science has absolutely no understanding of might just be the ultimate definition of stupidity. You need like at least a minimum of a seed of knowledge, scientific knowledge, to be able to engineer something. And we don't have it in AI. And people wonder why we don't have AGI today. So in around the year 2000, I decided that if I ever going to build AGI or ASI, I need a theory of intelligence, not just any theory of intelligence. I need a general theory of intelligence. And this is probably because I'm a Star Trek fan. So I truly believe that the universe is full of life. And I wanted a theory that could explain intelligence on any civilization anywhere in the universe, no matter how different they are from us. And this is a little bit different because usually humans do not have a good track record of looking at ourselves as a part of the universe. We've always been the center of the universe. We always looked at stuff from a human perspective. And I don't believe having a theory of human intelligence is good enough. So I wanted a theory that is general enough that can be applied to any civilization and in the world. That means um, the scary dude over here. Let's say that's a civilization on the other side of the universe. Maybe they're non-carbon based. Who knows? But the one thing we guarantee to have in common with them is that we are built of the same fundamental particles: electrons, neutrons, and protons. Okay, granted, protons and neutrons are not fundamental particles, but let's just assume it for this discussion. Anything above that particle level, who knows? So, can intelligence be described at that level so it is guaranteed to apply to anyone? That was a question I had. Then, about 5 years later, about 2005, I read a book from Jeff Hawkins. You might have heard his name. He's a founder of Palm Pilot. And after Palm Pilot, he went back to what he is passionate about, which is the human brain, the neocortex, as well as trying to build essentially a digital version of the neocortex as AGI. But in this book, he referenced Dr. Vernon Mountcastle. So Dr. Vernon Mountcastle is considered uh, the godfather of modern neuroscience. He wrote a paper in the 1970s. So I believe he was with John Hopkins. Um, he wrote a paper in 1970 that was so groundbreaking, so controversial, that his two co-authors refused to put their name on the paper. Um, which, too bad for them because he won pretty much every prize there was except for the Nobel Prize. But the big idea on that paper was that the neocortex appears to look the same. And therefore, it appears that what he was hypothesizing that every part of the neocortex perform pretty much the same action. And that the only thing that differentiated one part of the neocortex from another part is which sensory apparatus they're connected to. Therefore, the part of the neocortex that is connected to your ears process speech. The ones that are connected to your eyes process images. But the big idea here is that he believed and he argued that the human brain uses a common cortical algorithm. Now, Jeff Hawkins translated that into AI language. And he said, if Vernon Mountcastle is correct, then we should be able to create one single algorithm in AGI, an algorithm that can acquire every piece of knowledge in the universe and learn to perform any task without, that doesn't break the laws of physics, obviously. Clearly, with, you know, um, you know, in real life, you will have some hardware limitations, but forget the hardware limitations for a second. If the single algorithm was to be able to run on this magical computer, it should be able to acquire every knowledge and do anything that's possible to do. Now that would be, according to Professor Pedro Dominguez at the University of Washington in Seattle, that would be the biggest invention in human scientific history to find an algorithm that can do that. Most people in the world of AI do not believe this algorithm exists, um, but some do. Examples are obviously Pedro Dominguez at the University of Washington, Jeffrey Hinton, who just won the Nobel Prize in AI this year. He just told me that he's been looking for this algorithm for 40 years. So there are people who believe in this algorithm, and I'm one of them. But here is where I differ from Pedro Dominguez and Jeffrey Hinton. Pedro Dominguez believes that to achieve this algorithm, we can merge the best parts of current machine learning techniques. Jeffrey Hinton believes it will take more of a neuroscience understanding of the brain and see if we can somehow replicate that. I believe that the single algorithm would be a pure implementation of the nature of intelligence, whatever intelligent is. And therefore, that requires a scientific theory of intelligence. Now, I'm going to put my name on this because that is not a normal view in the world of AI. So I don't want anyone to confuse what's on the screen with what is common in the world of AI. That is my belief. So once I read this crazy idea that you can have this one collection of lines of code that can do everything that's possible to do, it I wanted to find that, and that meant I needed to go back to the most fundamental part of what intelligence is. So, intelligence before the era of large language models, back in the good old days, we talked about intelligence as has something to do with goal-oriented behavior. I'm sad to see that in today's era, and that includes everything I heard at TechCrunch Disrupt, no one talks about goal orientation anymore. It is like language is the thing. I've heard many people talk about how intelligent emerges from language. Well, I think that's, well, I'm not going to be politically correct there. I think that's stupid. That is like saying that the British people emerged from the English language, when in reality, the English language emerged from British people. I don't know if they called it British themselves back then, but um, language emerges from human intelligence, not the other way around. But back in the good old days, we talked about intelligence as something to do with achieving goals, or at least attempting to achieve goals. So I started thinking about, okay, what is a goal? Because even goal doesn't have scientific definition. In the world of AI, we talk about function maximizer, about creating something that becomes better and better at accomplishing a specific task. For example, there's video game stuff that Google DeepMind did about trying to get the highest score on one of those classic video games. But I'm thinking about, okay, if I want something to order me an Uber, I don't want this AI to become better and better at ordering Ubers. I just wanted to order an Uber so I can get to my first goal, so I can get to my second goal, to my third goal. So I started thinking about this thing as a thought experiment. Let's say I have a cup of coffee, and then I have a red dot that represents my goal. My goal is to get the cup of coffee to this red dot. So I push the coffee over, and now I have achieved my goal. I mean, objectively, I have achieved my goal. What does that mean? How do I describe it? Not how do I describe it using the words coffee cup and table and red dot, but how do I describe it in such a general way that it can apply to any imaginable goal that you might ever think of? And I realized really quick that if instead of looking at it as a coffee cup, what if I look at it as a collection of particles? A collection of particles that when I reposition those particles at the specific coordinates in space and time, I interpret as me having achieved a goal. So from there, I realized a simple, more scientific definition of a goal is a future configuration of particles in space-time. Now, take a second, think of any goal you could ever imagine. And that goal requires you to change the particle configuration of space and time before you can call it a goal. It is, even if your goal is to sit still on a table, you still have to have oxygen. Blood has to go through your system. Your heart has to beat. Every goal you could ever imagine requires a change in the physical world. Or if we wanted to talk about this in more physics language, a goal is a future desired entropic state. Now, that means if my goal is to find cure for cancer, have a great dinner party, get a job, whatever it is, it's a future desired configuration of the universe, which means intelligent, and this is what I argue in my paper, intelligent is a fundamental process in the universe to change the particle configuration of space and time. Or in more physics terms, it is intelligence is a fundamental process to control entropy in a localized area. Now, entropy is important here because according to laws of physics, the natural tendency of uh, the universe is to move towards higher entropy. So if you leave a building alone, eventually, after many, many years, it will start to crumble. But instead, we humans keep maintaining that building. In other words, we are controlling the entropy, the entropic state of the building, making sure that the entropy of the building doesn't naturally go to a higher level. So I think that is what I'm arguing intelligence is a fundamental process in the universe. Now that means that intelligence is really about chains of cause and effect, because cause and effect is what leads to changes in the universe. So, for example, if I press the start button on a coffee maker, then the effect is I have fresh coffee. Now, there's more to it than just that, right? Because the question is, where will the cause happen? Uh, if I press a button far, far away from the coffee maker, I'm not going to get the fresh coffee. So the cause has to be inflicted at a very specific place and a very specific time. Time is important here too, because I can't put my finger where the start button is before I buy the coffee maker. It has to be after I buy the coffee maker. Um, so it is if you're going to control the future to achieve that desired future state, you have to know when and where to inflict causes in space and time. So let's look at it from a more cosmic perspective. If we take the universe, so this is the block universe, where so this is the mainstream view of how the universe looks like. On the left side, you have the Big Bang. On the right side, you have the end of time. The belief is that the past, present, and the future all coexist. So let's slice it up. Let's just take two slices. Um, and let's say the right slice is the future state, and we are on the left slice. The right slice is what we want the universe to look like. So that's the effect. And that means that we have to initiate some cause in the first slice. And of course, the time difference between cause and minimum time is the smallest unit of time, which is we call Planck time, but there really isn't any maximum time. Here's the thing. If you look at it from cosmic perspective, that the entire universe just consists of a bunch of particles and a bunch of energies and all the fundamental stuffs in physics. That means that everything in the universe can be distilled down to cause and effect, and that includes morals, ethics, politics, economics. And I really highlight that because in the world of AI, we talk about morals and ethics and stuff like that as something magical that exists that AI will never be able to understand because whatever reason. But in the physical universe, the only difference is the arrangements of particles. And the only reason particles change location or energy levels is because some cause was inflicted into the universe. That can explain morals and ethics and your political view and your economics. It can explain literally everything in the universe. But it's also about levels of abstraction. So, for example, if I click on if I click on start and I get a fresh cup of coffee, that's technically is not real cause and effect. Technically, what happens if we go one layer deeper, pressing the start button turns on the electricity, which causes the fresh coffee. And then I can go a little bit deeper and say that pressing the start button turns on electricity, that turns on the heating element that eventually turns into coffee. And I can keep going lower and lower and lower until I can explain it at the particle level. Now, this is important because if you have an AI, maybe one day the AI realizes you want cold coffee. So it has to be able to go down in this layers of abstraction down to the place where the heating element is a part of the chain and do something to make sure the heating element does not get turned on. So when I'm thinking a single algorithm, I am thinking an algorithm that can learn cause and effect, can break down cause and effect to the smallest building blocks and being able to use that. Essentially, if you have the smallest building blocks of cause and effect, you can put them together to create any task you can ever imagine, even tasks that we humans have not even conceived of yet. And I think that's really, really important because in today's world, and I heard this a lot in Disrupt, is people talk about agents now. OpenAI is going to release, I believe, agents with their upcoming GPT-5. I've rumors. I don't know if that's confirmed or not. I know Anthropic has started talking about agent. Agent is becoming the big thing. The problem with agent is that an agent is a narrow task. Is designed by humans, developed by humans to do certain tasks. That means that that type of AI, in this case, the generative AI that controls agents, can't build new tasks that we haven't conceived of yet. They're limited to human knowledge building more and more agents. So let me share with you what we built. We have built what we call Prometheus, codename Prometheus. We don't call it a single a foundational algorithm. What it does is essentially using sensor data from devices, having streamed down to this algorithm. We take that observations and we try to put these observations together to kind of guess which observation is a cause and which observation is the effect of that cause. We're going to get it wrong, but as we see it a few times, we'll start knowing which is cause and which is effect. We have a distributed way of making sure we weed out correlation and find real causation. But we build essentially this, let's call it a database of casual knowledge. It's a lot more than a database. It's a layered hierarchy where different abstraction layers are stored of these cause and effect observations. But as we build this database, If you give this single algorithm a goal, it will spawn a model for reality. The more knowledge it has about cause and effect, the more accurate its prediction of how the future is going to look like. Will, how, the accuracy will be much higher, and it's able to plop in the goal into that model. And we then use essentially retrocausality to see how, by putting in a goal into the future, how does that come back to the now, to the present, and tell us which causes we have to inflict in an environment and where we have to inflict it to be able to get to that future where the goal has been realized. It's more than just trying to figure out where's the causes. We also have to find the best path to the goal. Best path is not always the shortest path because the best path does not interfere with your other goals, does not interfere with your friends' goal or your family members' goals. It does not affect, it doesn't challenge current laws or your moral or ethical views. So it's not always the shortest path. But once
I
we've decided on the right,
can can I ask a
go ahead.
question? How do you,
Yes.
I guess in a sense, how do you get everyone to agree on the same goal, right? Because it comes back down to you're saying it's not the shortest path. And so that's where I guess my question comes because I see that like, you essentially want to bring back the original definition of goals back into it and make this foundational algorithm work. So I
Yes.
guess my from like a viewer's perspective here, I just want to my question for you is that like, how would you even get everyone to agree on the same goal?
You don't have to agree on the same goal. And in fact, in reality, we will uh, actually, let me step back. This algorithm will run um, under your perspective. So everyone will have essentially their version of this algorithm running. And I'll give you a very good example of why goals cannot be agreed upon.
Mhm.
We are in the middle of a presidential election here in the United States. There's two people running for the presidency. They cannot both win. So just because you have a desired goal that you want to achieve does not mean that goal will be achieved. How we define who's going to achieve the goal, that becomes more of, let's call it a little bit of game theory. Um, but I go pretty deep into this in my book, but I still stay a little bit away from our core um, intellectual property on this because we're not trying to give everyone a blueprint on how we do this, but there are ways that we are thinking about how when two goals conflict with each other, for example,
Mhm.
how does the system decide which goal it should focus on? And in a way, it really comes down to kind of like how things work in everyday life. How do you get support among people to make sure that you'll get the access to the resources needed to actually achieve your goal? This is not something that the AI decides. It doesn't say, I don't like you, so I'm going to give the resource to someone else. It really comes down to how many, the only thing that the AI cares about is a positive outcome for as many as possible. So if your goal is very selfish, the AI will probably not give you as much priority as if it is, if the prediction of giving a resource um, to someone else, or I'm sorry, to giving a resource to someone else gives more value to more people, then it will focus on that instead. Um, I say resource because anytime you want to inflict something, a cause into reality, you need a resource to do it.
Right.
And the question is, if two people wants that same resource, but there's only one available, who gets it? And so the only rule we have built in is whatever creates the most positive outcome for the most people, either for your community or everyone as a whole. Now,
Hmm.
exactly how we do that, that's for that's definitely not for for this presentation. But at the end, what we do is we package it up. We call an intelligent briefing that says uh, what a device needs to do, when it needs to do it, where it needs to do it, why it needs to do it, and how to do it. And it sends that briefing to the right devices so that when the right things, I think of the intelligent briefing as an IFTTT kind of document. It's some rules that we ask the device to follow, and once they execute on whatever it is, the observation that comes back down to Prometheus will tell us if our prediction or if Prometheus' prediction was correct. If it's incorrect, it will learn from it and it will readjust its models to see if it can find another way to achieve that goal. Here's some examples from the last 10 years of what this one single algorithm has been able to do. On the left side there, we set up a scenario where we're supposed to be in a meeting. One person was late. He texted me, asked, "Is everyone there?" Now, the AI had learned that when you're in a meeting, you silence your phone. That's a common sense. So it had already silenced my phone, which meant I don't know, I didn't know that the text message came in. So it took care of it. It responded, "Everyone is here except for you." That question, "Is everyone here?" wasn't a random question we decided to test. And I think is more relevant in the world of LLMs. That is a contextless question. It's not a question you can answer unless you have a model of how the world should look like and what it actually looks like to be able to derive context from it. In the middle screenshot, the use case was we had a dinner party. I picked a recipe. There was milk in the recipe, but the AI told me to see that little triangle there, that if I clicked on it, it will tell me that if I use milk, someone is going to get sick, and it suggested a lactose-free alternative. What we're showing there is understanding the consequences of it, of the actions it's proposing. So by being able to use my friend's model and my model, how them work together, the AI detected that milk could cause a negative outcome. And it suggested, in this case, it did suggest a lactose-free alternative. So this is not things that the algorithm did per runtime. This was a continuous running algorithm that was learning in every field because the only thing the algorithm learns is cause and effect and using them to model the future. Not going to go into the engineering here, but just going to say that we don't believe that if we can grow this at the global scale, um, we don't believe that a single company or a single government should be able to control something like that. So we are designing it to be completely decentralized. So anyone can own a piece of it. You can put it on your home Wi-Fi and control the geographic area where your house is. City can put it in a park and control the park rules. Um, a company can put it in their corporate network. The idea here is that we can all own a little piece of it and all control a little piece of it. But the thing is, we often talk about artificial general intelligence or super intelligence. General intelligence is kind of like human level stuff. Super intelligent is beyond human. What we are looking at building here is an architecture for super intelligence, where you can get observation from around the globe and create, if you put all these models together, it becomes a global model and help us find global solutions or individual solutions. Where we at today is a baby ASI. You know, works on a few devices. The models are very limited because it doesn't get all the observations from the billions of devices. But that's really what our business is about, is to work with device manufacturers and network operators to get this into as many devices, ideally into billions of devices, that will essentially allow us to raise this baby to become more of an adult. In other words, this idea of an intelligence explosion, like Elon Musk and Bill Gates were on the stage a few years ago in China saying that if someone ever builds AGI, the moment you turn it on, it will go out on the internet, it will read everything and become super intelligent and dangerous. That, in my opinion, is just pure BS. Because if you're going to change the environment, you have to observe the environment, which means you have to get it into devices, which means you have to have a good sales team, which means this is going to be a much slower growth. And slower growth means we humans are always in control. So let me compare this to what I heard at Disrupt and generative AI in general. Generative AI is all about pre-trained models. Jan LeCun, who is not a fan of generative AI in the context of AGI, has always said LLMs do not work for AGI because we need models of the world. Some people have said, well, we can always train a generative AI on a world model. The problem with that is a fraction of a second after you've done training a model on the world, that model starts becoming obsolete because the world keeps changing. Our fundamental algorithm focuses on real-time models. It learns cause and effect and builds models when we need it, when we supply a goal. Agent technologies, that's the newest hype these days, trying to add agent technologies to make generative AI get closer and closer to AGI. Again, agents are narrow tasks programmed by humans. That's not going to allow an AI to grow into doing new tasks that we don't even know exist yet. For us, it's more about self-learning, breaking down cause and effect, and using the fundamental pieces to create new tasks. Extreme compute power with generative AI, because we're using decentralization, every small little node does not need a lot of power. So we don't have to worry about that part. And no comprehension. I think that's the biggest thing for me. You cannot have AGI. We talk about reasoning. Reasoning and comprehension are two different things. You have to truly understand the why. The question why is comprehension. We do that. We test actions in virtual models before we ask devices to execute. We test them. Will achieving this goal by doing X, Y, and Z, will that interfere with my other goals? Will it interfere with my friends' goals? Will it cause any harm? And only when we analyze all that stuff, that's when we ask devices to do something.
Excuse me.
Generative
Excuse me.
AI,
When you say we, you mean Prometheus does it, right? Not you, not the
yep,
designers.
correct, yes. The AI, not humans. um, I teach a class in ChatGPT, and I teach kids, and we talk about morals and ethics. And I ask ChatGPT, "Can you tell me how to successfully rob a bank?" And ChatGPT says, "No, can't help you with that." And I asked them, like, "Do you think ChatGPT has a conscience?" And the answer is no. It was pre-programmed with moral and ethics. And I don't think that's how we get to AGI. I think this idea that we want an AI to learn our moral and ethics and apply those in decision making, that is how you get to um, a better future where an AGI works truly for us, not for a corporation.
And we've
So
seen, just to say, and we've seen, them break ChatGPT with the right prompt, right? So it's not
that's
always
right.
not
That's right.
always efficient to assume that you
That
can
is,
teach it more.
yes, that is right. I try to do that too, and I can never, I always fail. So I'm not a very good
I
moral
don't think I
hacker.
want to break it that badly. I think that's really what it comes down to, right? So
Yeah.
so
Yes.
yeah, but we've seen it. So I think, I mean,
Yes.
yeah, thank you for answering my question earlier. My question really was about the constraints of the algorithm, right? And just what would go into it. In this case, yeah, you can't really sometimes the right prompt can give you the wrong answer, but for the right question you were asking.
Right. And that's because ChatGPT does not understand what it's telling you. There's no comprehension there. And I think we don't talk a lot about comprehension in the context of AGI. But I think at the end of the day, if you can't comprehend, you don't have true intelligence. But I just want to end with our vision. What we really want to achieve is we want to get through the great filter. I know Elon Musk talks about that a lot, but we have problems as a species. We're destroying our planets. We need to find cure for cancer. And I do believe that if we can build a super intelligence that can understand the fundamental causality of the universe, it can help us find pathway to fix our climate change, find cure for cancer, help us develop a propulsion system to get us into space. And so our main thing here is if we can get this at scale, what we really want to do, because this is all about resource management, capitalism. Today, resources are distributed based on the size of your bank account. Um, if we can create models that can predict the impact of giving you a resource, we can create more of a value-based resource management, something that allows humanity as a whole to move forward, not to move forward to a big bank account through greed, but through a better future. That's our goal. That's
I
really what we want to achieve in the long term.
I have a question.
That's us.
Excellent talk. I have a quick question. So I found that with technology, kind of like medicine, um, in order to help individuals, technology is going to have to be somewhat individualized. For example, if you're looking for cures to cancer, just using this as an example, it may not be one cure applies to all. It may be something where the knowledge about that person and their habits and their behaviors and their proclivity may be the root of how to solve that particular cancer for them. So if I have a cure for the same cancer that you and I might share, the practices and the diet, for example, may be very different for the both of us. So there'd have to be some observation by this system to understand what I do on a day-to-day basis before it can really arrive at a root cause. And I think once we get down to that level of granularity, then AI might be very useful. Do you foresee it getting to that point?
Yes, that's the whole idea of this financial algorithm is to break things down so we can understand essentially the first principles of everything. So it's a reductionist view. So if we can get it to observe what cancer is, um, we can, I believe, we can get it to understand how that cancer um, comes about and how we could get rid of it. And I'm being very careful here because I know nothing about cancer. Um, but I think once it learns that, and it learns that as a negative thing, that it's something it does not want to see in a model, in your personalized models, I think what we will end up seeing isn't uh, a constant race to find that cure. It's to make sure that that never happens in the first place. And I think that's the ideal future. It's not having pharmacies everywhere. It's to make sure we don't need pharmacies.
I agree.
Any more
So yeah,
questions? The
that's it.
floor is open. We have a few more minutes. Oh, Renee asked, let me read it. Do you think it is the duty of a human being or any other life form to create something bigger than itself? Otherwise, the conclusion might be that the life form fails to understand its own way and purpose of creation. Or would that conclusion simply reflect human egocentricity?
Well, we are talking a little bit metaphysical here, I think. Um, do I believe that? So I believe I'm going to be a little bit careful because I don't want to go too much into religious beliefs and stuff like that. But I do believe in a way we don't know what the universe is, number one. But I'm pretty confident that we are stewards of the universe and of our planet. And I think that if you take all the civilizations in the universe, we're probably stewards of the universe. I do believe we have a natural, um, I do believe it's built into our DNA to make life better. And I do believe that the only way to make life better is progress, is technological progress. And I do believe that's the only way we can survive as a species. So, will it? I don't think it's what do you call it, egocentric? I no, I would disagree with that term. I think I don't know. If you look at the history of humanity, we've always done progress. It's in our blood. It's in our DNA. We know Earth is not going to last forever. We got to get off this rock as a species. When I say get off this rock, I don't mean in our lifetime, but we got to make progress towards it. Um, so I do believe we have a duty to make sure that future generations have what they need to continue survival.
And that's great. Great answer. And Ananya also she said, thank you for the deep science perspective in your talk. How would you envision a personalized model evolve to the target state?
Um, I'm not sure what you mean by target state. Can you elaborate on that?
Maybe I can voice it.
Sure.
So yeah, thank you for the talk. What I mean is, as you mentioned, LLMs right now, before it gets to the consumer's hand, is pre-trained, fine-tuned, dragged, all of that stuff. So what I gathered from the vision of personalized models, like in a person's hand, serving the person to cure or prevent, right? It's going to be a journey from that. So I guess, like, have you guys already thought about, like, say, a couple of high-level milestones where the LLMs agents of today would reach this personalized part, especially from, like, we've heard personalized medicine for like decades now, and we're still suffering through it. Um, so, so that's what, like, I'm sure there's no right answer, but since you guys have already dived into it a lot, so, like, is there, like, kind of envisioning of, like, how to get there?
Sure. So, in 2016, we did a pilot in Portland, Oregon. We told a group of testers essentially that they're going to put an app on their phone, and the app is going to do nothing. It's literally just going to sit there and watch them and learn. And then we cheated. We gave everyone um, movie tickets, and we said, "Hey, go to the movies." And within 2 or 3 days, it had learned that it's common sense to silence your phone and turn on the screen brightness on your phone when you go to a movie theater. And a few months later, I was in Morocco and I actually just stopped by a movie theater, and it thought I was going to watch a movie, so it did exactly the same thing, even though no one had ever gone to a movie theater in Morocco. So what I'm trying to say is, um, so we're going to start launching this to people in 2025 at some point, and it literally is going to start as a baby. It's not going to know much. It's just going to learn the basic stuff in life. We have some limitations of what it can learn, that we kind of been inspired by babies and toddlers. Um, to make sure that it does not learn stuff that's too complex right away. It learns the basic stuff. It will start automating your phone. It will start launching an app. It will start learning basic language. We worked with a group of teachers at the school district in Portland, and to try and teach it language. We wanted our goal back in 2017 was to get it to a point where it could read a child's book and actually understand it. So it's going to be a long journey, and I wish I could say exactly how it's going to learn stuff. I can't. Um, but we're going to treat it as a baby, which means this is not a technology that's going to be a shiny object. People are not going to go look at it and go, "Oh my gosh, this is great. It's going to take over LLMs." It's not. It's going to be pretty mundane and boring for people who are looking for shiny objects. But for people who understand where this is heading, I think this is going to be pretty exciting. One other thing though, there is a security mechanism built into this. So if the confidence level of an action is below a certain threshold, your phone or whatever device you're using is not just going to auto execute this action. It's going to ask for permission. And you, as a user, decide that threshold. You might say, you're going to ask me for permission for everything. Or you can say, if you are 75% sure, go for it. It's really up to you. But to raise this, to raise this from a baby to an adult, we are going to rely on super early adopters who understand where we're heading and are willing to deal with being a parent essentially for a baby at ASI that does probably a lot of wrong stuff.
Can I add
I
to
don't know if
that?
that answered the question, but
Can I add to that? This is not
yes,
LLM.
go ahead.
This is not LLM based. By the way, I'm Steve Taylor. I'm Mounir's partner in this event. And we are not, everybody thinks you have to take an LLM and use it. This is another technology that doesn't demand NVIDIA chips and huge power, but it's a baby. And think of how you raise a baby and the growth stages babies go through. You're not going to try to teach a baby about complex economics when it's young. It has to start learning how to deal with the physical world. And that's the same thing we're going to end up having to help teach it. We are not going to pre-train. There's no training here. It's learning. It's a whole different way of looking at the world and AI.
Rather than the approach now, which seems to try and teach everything all at once and hope
That's right.
right.
And of course, we'll ask it to recognize cats because otherwise we don't have anything real. That's a joke.
Absolutely. And I guess this question, one of our last questions we have, Gabrielle asked, could this algorithm educate and combine other algorithms? And I think that you guys are basically talking about that when you say that you're going to slowly teach it other algorithms as it goes along.
Let me give an example on that. I'm not going to mention the name of the company, but let's just say it's Oregon headquartered, very large sports apparel company. You can take a wild guess what I'm talking about. But many years ago, they wanted to test this out. They wanted to see if we put this next to one of their most basic cybersecurity detection systems or algorithms, if this thing could just learn what comes in, what comes out, and kind of learn from what it does. And then once it could just mimic that, take that away, put the next cybersecurity uh, system, because they have like tons of it to protect their corporate network. And the goal was, can it eventually learn all of them? And yes, can it learn all of them? And so that this AI system could just by itself become a cybersecurity expert and learn how to protect the network. So that would be learning other algorithms and digesting that to not only digesting it, but understand what they're doing to do the job better. Unfortunately, we never got to do that because half of the cybersecurity team got laid off in a big layoff round at that point. So we lost that. That would have been a very interesting test case, but um, maybe we can do that in the future with someone else. So we'll see. But again, I don't. That would have been a control test case. because a baby SI shouldn't be learning that stuff right away. But it did show that, um, well, it would have shown if it was successful that this algorithm can learn from other algorithms.
Well, this was a great discussion. Thank you for joining us and teaching us all about this. Now I feel like I'm going to think of algorithms in a lot of these new organizations that pop up the same way, because our approach so far has been teach everything at once, hope it works, fix it as it goes, rather than the slower but methodical approach of teaching it little by little. So yeah, thank you so much, because now I feel like I will look at it also differently. Thank you for joining us, and yeah, if you've enjoyed this talk, please join us again next week. This is our lunch and learn. We always invite speakers like Mounir to come and teach us something or make us think of something that we've known about for a while, but in a different way. So thank you everyone for joining us.
Thank you.
Thank you.